And he's the author of many, many, many books, and we've been going back many years. So Rory is like the big brother of I wanted to say the worm, eh? But then he's going to smack me when he sees me again. But so he's like the father of project management development, really in the world. Started his life in the Navy and went past South Africa at one stage. But it's always fantastic just to chat to him. So you all know, obviously, that we're using the book that you're seeing there, the AI book. But so Rory, I'm not going to waste any more of your time. So welcome, Rory, and thank you very much again for joining us. And Marie, thanks for organizing it.
Okay, well, Peter, thank you for the introduction, and thank you, Marie, for the organization. And it's a pleasure to do another presentation for your course and your delegates. And of course, thank you very much for using my book. I think this is the first time I've been called the father of project management, but I guess that's a reflection on my age. I can sort of agree with that, because when I did my master's in project management at Henley, which would have been 86, 87, it did precede the body of knowledge, the PMBOK, that came out in the 90s. So Marie, if you can go on to the next slide, please. So I'm working on artificial intelligence at the moment, and a few years ago I was talking with a professor in South Africa, and he this must have been 2018, and he kept talking about Industry 4.0, and this is not a term which is used in Britain. Britain tends to talk more about AI. So I thought, what a strange term, and it got me researching it. And I have a background in computer-aided engineering from Coventry University. So I started to sort of join up the dots. And as I researched this, I felt this is going to be big. And I started to gather together data to write a book on for an MBA type program. I got so far and then felt I needed to update one of my project management books. That's the one in the top right-hand corner there. And so I started to look at the techniques that could be used to plan and control projects, and I've picked up quite a few of them. I would say they're still in their infancy. So a presentation, it really is about the concepts and what's going to happen in the near future. So the way I want to structure this presentation, I'll start off by talking about industrial revolutions, and then you'll see where Industry 4.0 comes from, or the fourth industrial revolution, with respect to the other three. I'll then talk about Alan Turing, who I call the father of AI, and then I'll talk about a new structure I'm using at the moment, which is the hierarchy of AI. So I got this idea from Maslow's hierarchy of needs. In fact, I've used exactly the same template. And if I was going to put a name to it, I could now call it Burke's hierarchy of AI. And the way I see it, it's split up into 5 levels. And I'm going to start at the bottom level, which is the sort of computer-controlled machines, whether you call them robots, drones, industrial robots, GPS, anything that is a mixture of cyber and physical, which would be computers, and physical will be the machines. And then the next level up is how you're going to gather all the data on the performance of, whether it be machines or other aspects of your project. This is where they use the Internet of Things. That's the software term for that, and I'm using it in a much wider sense, not necessarily with computers. Then we need to model that to see how our planning is, and now we're calling these plans digital twins, and I'll explain what that is. And then the next level will be how we actually solve whatever problems we have, which will be expert systems. And then at the top level, we've got machine learning, which is how we actually learn from what we've achieved so far. So Marie, could we go on to the next slide, please? So I thought I'd just give you a little bit of background. Peter did mention that I've got a background in naval architecture, and that's actually what got me to South Africa in 1980. I joined the South African Navy and was involved in designing some of their ships. Then I moved on to other projects in South Africa. So that was a really busy time for marine and engineering type projects. Also got a degree in computer-aided engineering, which I mentioned, from Coventry. And then my master's in project management at Henley. It was a joint Henley and Brunel University. So academically, that's my background. So Marie, could you do the next slide, please? And just a little bit of marketing here. So I've got 4 books in my project management series. So the book you're using is the second one. The fundamentals is more for I call it people new to project management, sort of undergraduate. And then I've also looked into entrepreneurship and leadership, and the advanced project management was more looking at program management. So next slide, please, Marie. So this is a template I've got for the industrial revolutions, and I've written a chapter on this in my MBA book. And what I've done is I've just subdivided it into the 4 industrial revolutions. So those are the columns. And then within each column, I've got about 8 different rows where I look at the fuel, the transport, the engineering, the communication. So it comes out as a bit of a matrix. But I just wanted to point out that why we're now calling it the 4th industrial revolution. And just to give you an idea, if you can go on to the next slide, Marie. If you look at the top left there, it shows a canal boat. So anyone who's been to Britain, you might have seen these canal barges. And this was one of the things that actually got the industrial revolution in Britain going. They started that prior to the canals, it was essentially horse and cart. So you can probably visualize how much a horse and cart could carry in coal, and probably the roads would be muddy. Then came along the canals. So with a canal barge, and here's a good example, you've got one person steering the barge, and you've got one person guiding the horse that's pulling it. So if you remember, they didn't have machinery at this point. This would have been late 1700s, early 1800s. But you could visualize that barge is probably carrying 100 times more than the horse and cart could. And that's what I'd call a revolution, sort of a step change, a paradigm shift. It made it much more efficient. Then came along, if you look at the top right, so that's an example of oil. So the second industrial revolution was all about oil and the motor car, the motor engine. And this is when Ford came along with these production lines. So that was that type of industry. And that probably took us up to the Second World War. The bottom left there is nuclear, and the bottom right is wind turbines, which would really be the area we're in now. They talk about sustainable power, wind, solar, tidal, hydro. However, in Britain now, I think they'll take anything they can get, because they've backed themselves into a corner. So another aspect of the 3rd and 4th industrial revolution would be computers. So computers are very much the 3rd industrial revolution, the internet, and the difference with the fourth is more the level of connectivity. So with mobile internet and smart sensors, then every aspect of every job can be interlinked and tracked, monitored, and controlled. And this is where the strength will come in the fourth industrial revolution. Do you want to go on to the next one, Ray? Peter, do you want me to stop as I'm going along to see if there's any questions?
Rory, they will actually post the questions or interrupt you. They know, so they'll either we'll just look at the chat, and they'll either ask the questions on the chat or they'll just put their hands up and ask you.
Okay, well, has anyone got their hands up?
Not yet.
Right. Right, well, let's move on to Alan Turing. So I always like to feel that with science and engineering, there's usually a person associated with it. So if someone was talking about gravity, it would be Isaac Newton. Something to do with relativity, it would be Einstein. And have you got your name associated with anything, Peter?
Not really yet, Rory.
Yeah, okay. Actually, when you comb your hair up a bit, you do look a bit like Einstein occasionally.
Especially when it gets a bit long.
Yeah.
But normally people say to me, I look like Einstein just before they tell me he was an ugly bugger, Rory, so I don't know.
Yeah, okay then. Well, anyway, Alan Turing is the person, well, if I should say, the person the British people associate with artificial intelligence. The Americans, I'm sure, have got somebody else. So so I'm going to put forward Alan Turing. Now, I'm not sure how well Alan Turing is known in South Africa. Essentially, he made his name at Bletchley Park, which is the building on the bottom left. And that's where Britain was trying to break the German Enigma code. And the little typewriter there in the middle is the Enigma machine. And you might have recognized the film bottom right there, the Enigma game. That was essentially a film about what Alan Turing achieved. But he actually had his fingers in a number of pies, and he would have been working with other people. So he actually wrote a paper which he called Machine Intelligence in 1948. So they were talking about it then. And he was looking at programs that could self-correct. And that's essentially what machine learning is, that you write a program to achieve an objective, and if it doesn't achieve it, it makes small changes until it does. But the other thing he was involved in is one of the first computers that they used at Bletchley Park was called the Colossus, and it was full of valves and other type of hard electrical wear. And if they wanted to change the computer to do another type of calculation, they would literally have to rewire the whole computer. So, I mean, that could take days. So Alan Turing felt that there must be a better way, and he called it the universal computer, so that your computer could actually do many different programs. And that's essentially what we've got today with our operating system. It will allow us to do lots of different programs. So this, in a way, does go back to Alan Turing. And then just to finish on him, he came up with what we call the Turing Test. And this relates to a game which they used to have in the 30s and 40s, which was actually called the imitation game, which is how the film got its name. And this would be where a group of people it was like a party game. A male and a female would go into different rooms, and one would pretend to be the other, and they would ask them questions, and in writing, and it would come back in writing, and they would have to try and guess from the answers who was who. So Turing took this idea and switched the to a person and a computer, and so and the questions would then be given on the computer, and if the person who was interrogating the two couldn't tell which was the human and which was the computer, then the computer was deemed to have artificial intelligence. And I'm sure you've got Alexa and Siri and any of those questions. So they're sort of early stages of the Turing test, where you can ask them questions and they come back with their answers. Marie, would you like to do the next slide? Any questions on Alan Turing?
No, sir, everything's good.
Okay. Right, let's go on to the hierarchy now. So I'll start at the bottom, which is the cyber physical, then Internet of Things, digital twins, expert systems, and machine learning. So I'll do them from bottom up. And the sequence actually works quite well together, that the machines or whatever is doing the work will then provide information on the progress. It will then be compared with the planning. The expert systems will solve any problems, and machine learning will improve the systems. Next one, please, Marie. So if we think of cyber physical systems, which is a term I suggest you should just think about. It sounds more complicated than it is. Cyber essentially means anything to do with computers, and physical is obviously a machine. So it's the two together. Now, CNC, computer numerical control, flexible manufacturing systems, they're very much sort of early days of how this technology, this would all be sort of post-war stuff. Then I'm also going to introduce robots, particularly industrial robots, 3D printing, and GPS. So these are all good examples of what would be cyber physical systems. Next one, please, Marie. So if you look at top right, that would be a classic example of industrial robots, and I'm sure they've been in South Africa for quite a while in the car plants. They were one of the first to start using that technology. So they're doing the same job on every car as they come along. They're not mobile. They'll be on a fixed base. And you can just imagine if the car was slightly out of position, you'd end up with a window in the back seat or something like that. But this technology is where it started. Now, one of the differences between, I would see the car plants as being third generation, and a mobile robot would be fourth industrial revolution. Because mobility is majorly difficult for a robot. Obviously, something we humans can do very easily, but getting a robot to do that did require a lot of computation. Also, it would need communication and powering, and whatever the application is. Robots date back to Isaac Asimov. I think I'm right in saying he coined the phrase, or he certainly wrote a book called I, Robot, which started people thinking along those lines. We'd like to go on to the next one, Marie. So drones, another example of cyber physical. They actually started around the time of the First World War. If you could visualize, so Britain had their their battleships, their dreadnought type battleships. And then came along aircraft, and they weren't really set up to shoot down aircraft. They were more set up to shoot other battleships. So they needed to develop their techniques, and they needed some target practice. Now, as you can imagine, I don't think there are probably many volunteers for pilots to say, right, well, I'll fly along here, you see if you can hit me. So it was more a case of towing a drone or an automatic. I don't know if they would have had radio controlled in those days, but that's sort of where drones came from. And there was a lot of development in Northern Ireland when for the bomb disposal military, where they had a lot of problems. And then the example I've got on the bottom left there is called a HAL, high altitude, long endurance planes. Now, this is an example of a plane that the wings are just total solar panels. So as long as they can get enough sunlight during the day, and these tend to go up to the stratosphere, so it'll be all sunlight there. Enough sunlight to charge the batteries, then they can literally stay airborne for weeks, months, until they really need to come down for maintenance. And one of the concepts of here is that the drone part is just to have a platform in the sky. Then they would typically have a payload, which could be communications, could be observation. So there could be many practical applications for that. Do you want to go on to the next one, Marie? Now, I've got an example here of a pizza delivery, but could you imagine how this could be used on site to go maybe drawings, something like machinery, parts to be delivered. That could be very efficient. Also, I think this could move into quality control, that they could observe work that's happening and maybe even sign it off from what they see with the drone. Also, drones can be used in dangerous environments. I'm familiar with them being used in the marine industry or in the offshore industry, where they would go into areas which they would have to shut down production if they put a human in there, but a machine would be different. And one of the big things on site is losing equipment, not knowing where it is. So you can just imagine if you're able to fly a drone over and locate all your equipment, that could be very useful. Right, so the next one, Marie. So 3D printing, I see this as being another area where there's going to be a lot of developments, and the aero industry's pioneering a lot of work here. And one of the benefits is that with 3D printing, they're able to make curved surfaces. So companies like Rolls-Royce can actually make an aero engine which has got less parts in it than making the components from standard machining. Also, they can print on demand, which means that if you had the facility on site, you could actually produce what you wanted when you wanted. And just to give a personal example, bottom left there shows a wind vane for monitoring wind speed and direction on my boat. And my mechanic, who has a background in, he's a fitter and turner, the tail actually broke off my wind direction. So I knew how fast the wind was going, but I didn't know what direction it was coming from. So I asked him if he could just put a tail on it. Anyway, he took it away and he came back a few days later, and he completely made a new component, and he printed it. He 3D printed it with a plastic type of material. And you know, there's going to be a lot more of this. Marie, would you like to go on to the next one? Okay, let me just ask again. So I'm now going to move on to the Internet of Things. If there's any questions on cyber physical systems, which essentially is where all the work is taking place. Everyone okay there, Peter?
Prof, sorry, I just want to ask you something regarding all these info and those incredible things that you show us and tell us about. What is your thinking around the fact that people say, due to all these developments in the AI part of the world, that it is going to take over the human race, that it's actually too late to turn it back?
Yeah. Now you see, that's where I would see machine learning coming in. That everything up to machine learning would be humans using a computer to do what they want it to do, like doing your accounts or your GPS, working out how to get from A to B. So if you go back to so when I started my career, it was really before PC computers got going in the 70s and 80s. And then they were talking about the same sort of possibility that computers will take over and also take over jobs. And certainly a lot of jobs did go because of that, but also a lot of new jobs were created. So it has made life a lot easier. But I want to sort of sidestep that discussion. And I'm, well, particularly with my MBA book, I'm more looking at business opportunities of using AI technology to enable you to either perform the tasks you want to do or you know, to be in business. And what you've got to be careful of is that if you don't use new technology and your competitors do, then you might well find yourself out of business. So at the moment, I don't think you have a choice. You are going to have to go down this route.
Thank you.
Okay. Right, so let's move on to the next level. So this is now the Internet of Things. And if this is the first time you've heard this term, I can remember the first time I heard it, and I'm thinking, what an odd term to use. Because a thing, it usually talk about something being a thing is if you haven't got another word for it. Anyway, I'm so used to this term now that I just accept that this is what it's called. So if you look at the diagram I've got there, I've just showed a typical arrangement where there's 8 things, and each thing will have smart sensors. So a smart sensor, I mean, if you just think about your fridge, for example, you've got a thermostat there, and just imagine that thermostat had could transmit to a central controller, which could well be your mobile phone. You would be able to control the temperature of your fridge. So at the Internet of Things level, it's as simple as that. Now, the restriction at the moment I see is that smart sensors are expensive. But I'm sure in the next few years, these will become commercially available, and they'll just be a rand or so for these sensors, and they'll be everywhere. So you'll be able to sit in your office or whatever, and you'll be able to get data from all the machinery, equipment, appliances that you're interested in. So the idea is that the data goes from the smart sensors to a central controller, and then that central controller will pass that on to a digital twin, which we'll come on to in a moment. So the Internet of Things can be as big or small as you wish. And I think in the short term, or now, you might well find that if you consider this as a template, that this is a communication template. So you will already have a means of gathering data. It could well be verbally, it could be in reports, it could be in meetings. So I see that at the moment we would have a whole mix of ways to gather data, and very loosely I would call that your Internet of Things. Any questions on that one? Marie, do you want to go? I've just got a couple more slides on that. So the next one is, so obviously this is the ever given that blocked the Suez Canal for a while. Just imagine that you had track and trace on all items on that container ship, and I'm not sure if they have, but that technology is certainly around at the moment. You know, if you buy anything from, have you got Amazon in South Africa, or those type of companies, they'll be, you know, track and trace on all their deliveries. Now, just imagine applying that to your projects, that every item of procurement can be tracked and traced, and you just get a summary report. And Marie, do you want to go to the next one? So this will be just an example of resource management. If any of you were involved in the Moss Gas project, this would have been a typical arrangement where they'd hired these enormous cranes, which would have had something like a 2-year lead in for a weather window during your summer to do those sort of lifts. Again, gathering data on the resource availability, equipment availability. And you can apply this Internet of Things right through all the different knowledge areas. Marie, next one, please. So the digital twin, this is a term coined by NASA. So historically, NASA, when they sent a spacecraft into space, they would have had a replica, an exact replica of that on the ground. And they call that pairing. And if any of you have seen the Apollo 13 film, there's a good example there where they wanted to reduce the amount of power the spacecraft was using. So they had someone on the ground systematically going through different circuits, removing them and seeing if they could still restart the engines. So that was the level of their technology at that time. Now, a flight simulator is similar to a digital twin, except that it only represents the plane in a certain circumstances, whereas a true digital twin is an updated replica of whatever you're interested in, and it's live. So as you use the vehicle or whatever, it will change. If you could imagine, let's say Peter and myself bought the same car. Now, I do know that Peter loves Mercedes. I think he told me his dream car is an ML. Is that still the case, Peter?
Very much, Rory, when it's not Jaguars.
Yeah. Well, you see, just imagine if Peter and myself bought the same type of car. So to begin with, you could say that our digital twin of our own cars would be exactly the same. But then as we use them, we'd use them slightly differently. We'd either do more or less miles. Peter might go off-road into the bush and look for elephants or whatever. And he might have different wear and tear on his bearings and the like. So the two vehicles will become different as they're used. So the digital twin of each one will be different. And this is one of the key features of this technology. And then also, once you've got a model, a digital model, you can then do what-if analysis. You can vary the different parameters and see what the effect is. So it's a very powerful device. Can you go on to the next one, Marie? So from my background, I actually had, once I qualified as a naval architect, I actually had 3 jobs model testing. And one of them was with the Admiralty Experimental Works near Portsmouth. And this was in the 70s. So a lot of development on submarines there. So the one I was working on, it was the Churchill class, and the HMS Conqueror, if you know your history of the Falkland War, it was one of those. So I was essentially dealing with a model which represented all of them. But we were trying to correlate what would happen in the tank to what would happen to a full-size ship. So early days of digital twins, as it were. Marie, can you go on to the next one, please? So just to give you an example, your bank account is a digital twin. It's got all the features of what I've just been saying. So they're usually fairly quick. When you do a transaction, it would show on your statement quite quickly, and it will show your money in, money out, your balance. So that's all the properties of what you'd expect with a digital twin. So the next example there is the CPM, the critical path method. Again, that's a digital twin of the logical sequence of work of your project. And as the project progresses and you update the details, you have a live replica of your project. And then the bottom image there, bottom right, is the project plan, which is now an integration of all the different techniques. I've actually got it on the next slide. Can you go on the next one, Ray? So that shows, this will be in the book somewhere. I use this as a flow chart to show how time, procurement, resources, cost management all relate to each other with respect to the project plan. There's an integration there. So as the project progresses, your planning will, your actual will be different to your planned, and that your model needs to reflect that. So very much that's a digital twin of your project. Can you go on to the next one? So predictive maintenance is one of the techniques that's coming out of this. So if you're getting true data from your smart sensors, maintenance can change from, I'll just give an example there. Maintenance originally was probably reactive. So in other words, you didn't do anything until it broke down. Planned maintenance, if you think of your cars, you might service your car once a year. Now in Britain, that would typically be when they have a test, which they call an MOT, Ministry of Transport test, which sort of certifies the car as fit for being on the road. I seem to recall South Africa hasn't got that. But anyway, people in Britain would tend to have their service done at the same time that they take the car in for their MOT. Now, if you were to just consider your oil, for example, it may well say change the oil every 10 years, every year rather, or 10,000 miles or kilometers. But if you went to predictive maintenance, you would have a sensor in the oil measuring the properties of the oil, and you would change that oil when it was required, and it might be sooner or later. So you are sensing and predicting when things need to be happens, because what you want stop is unplanned stoppages, because that is the most disruptive and expensive. So you'd rather take a machine out early, tell people it's not going to be operating, rather than have it break down in the middle of a job. So again, this is a way AI is going to give you, well, just increase your efficiency. Right. Rory, do you want to go on to the next one? Okay, so we're going up to the fourth level now. So this is your expert systems. So an expert system is essentially a supercharged database. So where things like Google is really a database of facts. You ask a question and they'll give you an answer. And the expert systems have taken this a step further to, you'll identify a problem and they'll come up with a solution. And the way they do this is that they use what they call an inference engine to link the question to the solution. So the knowledge database is developed from statistical, from experience, and it would obviously be tailored to whatever your discipline is, and so it'd be quite precise. And there are examples of this. I feel there's still a lot of development in this, but this can also work not just with a computer base, but also with a person. So we can go on to the next one. So this is where what they're calling augmented reality. So there's a continuum, which I haven't actually shown here, between augmented reality and virtual reality. So augmented reality means that part of what you're seeing is real and part of is on the computer, whereas virtual reality means the whole lot is on the computer. It's all a computer-generated image, and there tends to be a sort of, the two tend to mix together. But augmented reality in its sort of true sense would be, if you look at the girl on the top right there, so she's wearing a headset which will have a camera in it. So the camera will be seeing what she sees and then sending a video to whoever is the expert. So then the expert sees what you see. So this could be really useful. Imagine you're on site and you come up to a machine or a situation, and you can now send an image back to an expert to discuss this. Now, in a way, you can do this. I've seen this. We're doing an extension on our house at the moment, and the builder was doing this with one of his men who was working on another job. He just got the mobile phone and he was videoing what the area he had a concern with. So this technology is already out there. The other thing with augmented reality is the head-up display. So in other words, as you're looking at the job in your line of sight, you can get data. So obviously you can call up the computer on a Siri type or Alexa type and say, please show me a diagram for whatever this job you're working on. So I see this has been an area where there's going to be a lot of development. Any questions on expert systems augmented reality? Right, the final level. Can we go on to the next slide, please, Rory? So this is machine learning. Now, I'm going to give a very simple example of machine learning because this is not really where I'm focused. And as the person who asked me the question, machines taking over the world, this will be the area where it would happen. But the very simple example I want to give is a situation I'm familiar with my writing and publishing. Is you can have warehouses full of equipment, components, products, whatever. And I remember we had a problem with one of our books, which we'd printed in Cape Town, and we needed to have a look at the books because there was a damage to some of the covers. And they went to collect the pallets, and they were collecting them from all different locations. And I was thinking, well, why don't they put them all together? But you see, it doesn't need to work like that. They purely take the space that's available. They register where it is. So when they want to find it, they just go to the location where it is, which is actually how your computer hard drive works. And that's when you do a defrag, you bring it all together. Now, just imagine you have a supermarket. So, Peter, imagine the last time you went shopping. You would find all the similar products are together. So all the teas would be together, all the apples, all the meats, all the wines. They all tend to be in the same location. Now, if you used machine learning, if you had a situation where the picking of the food was done by a machine, not a person, all the robot would need to know is what location it's in, and then and the computer database would know that. So the most efficient way of picking is to have the products which are used the most at the front. So a supermarket based on machine learning would reorganize all the products with the most used first. So you'd find the tea that you'd used first, which I seem to recall in South Africa is 5 Roses. And then a little bit further along, you'd have the other tea like Rooibos. And maybe right at the back, you'd have the tea I normally have, which is Earl Grey. So everything's sorted in how it's used, not all grouped together. And that would be my example of machine learning. Right, any questions on that? Because I'm now going to sum up. No? Right, so I'll just very briefly go through what I've done. But anyone who's been asleep, now's the time to wake up. You're still awake, Peter?
Very much, Rory. I'm recording you.
What, so you can listen to it later?
No, so I can sell it. That's my ideas.
Yeah. Well, I have to tell you, I remember going to a lecture on wave power generation at Southampton University. And I had an interview the next day with a model testing establishment. And I fell asleep during this lecture. And I just woke up at the end when the professor summarized what the lecture was on. And sure enough, at my interview the next day, they asked me what was my opinion on wave power generation, because this was quite topical at the time. And I just remembered the 5 points that he said. I didn't remember his presentation at all, just the 5 points. And I got the job.
Brilliant.
Right, so just to quickly recap what I've just gone through. So I started with the industrial revolutions, and we're in the 4th industrial revolution. So very much it's the internet, it's the connectivity, and this is only going to grow as smart sensors become commercially available and the computer algorithms get a little bit more powerful. This is the way it's going. So if you wanted to put a name to it, Alan Turing is the one that used from the British side. And actually, I'll give you an example of a £50 note there. This has come out in the last year or so. So he's actually on the new £50 note by popular demand.
Just for the record, that's 1,000 rand, a £50 note.
Well, that's nothing to you, Peter, is it?
No, because I don't know those things, Rory.
Yeah, actually, I gave a lecture the other day, and I asked the students, anyone got a £50 note, and one of them did.
Okay.
He was from Nigeria.
Oh yeah. Okay, that makes sense.
Yeah. Actually, one of the interesting differences between Britain and South Africa, most of the master's courses, well, particularly in project management, the students will be from Nigeria, India, and China,
Okay.
and they'll be most of the students.
It's like, Rory, in New Zealand, the in-class on the MBA. So not the distance learning, the in-class. I promise you there, we can have an MBA class of 40 people that there's not one New Zealander in. All from India and China.
Yeah. What about South Africa?
No. South Africa, there could be a lot of neighboring, so a lot of Namibians, a lot of Botswana, Zimbabwe maybe, but very few other ones.
Yeah. And what about your group here, this one?
No, I think, well, obviously we see Lesotho as part of the Free State, so I apologize to the Lesotho people. And I think we might have a few Lesotho people, and we definitely have some Namibians in here, but the rest all South Africans.
Yeah. So that's unusual in the British sense.
Yeah.
Right. So where was I now? Okay. So the hierarchy, the Burke's hierarchy of AI. I must patent that somewhere along. This is a new idea I have. This is actually the first time I've done a presentation on it. So I do see a link here. I would, in the past, I would have called this a continuum, going from machine learning to cyber-physical. But I do actually see that there are stepping stones here, that you start with the equipment, you gather the data, you compare it with your plan, you solve your problems, and then you learn as in a learning organization. So I'm actually still working on this. Now, just to give you, Marie, can we go to the next slide? This is, I can't remember actually where I saw this sketch. I thought this is quite an interesting one. So this sort of fits in with that question I was asked. And not so much as computers taking over or robots taking over. And in some respects, you actually do want them to take over the more rote type of work. And you see it in the large sort of warehouses of Amazon and like. They're moving goods along conveyor belt systems, and a lot of the food would be processed this way. But someone's got to write the controls. Somebody's got to maintain the equipment. There's still room for the humans yet, but and another point I wanted to bring there was with more automation, you might argue why would you send your work off to the east? So very much the outsourcing was done because of labor rates. So particularly in the West, the labor rates in the East were a lot cheaper. So that's where the manufacturing moved to. But now, if your manufacturing plants are automated, then why wouldn't they move back to the West? And there is some data coming out of America that although AI was taking over jobs on the production line, the workforce actually grew because the work is coming back from previous work that had been outsourced. And this is sort of fitting in with, I mean, Britain's just got a new prime minister as of yesterday, and major problems with power. They're calling it a cost of living crisis. They're even suggesting there could be power cuts, which of course is nothing new for people in South Africa. But I think we could be moving to a situation where we're moving away from globalization towards protecting strategic supplies. And this is going to, in itself, is going to generate more local jobs. So just the last slide there, Marie. So that's the end of my presentation. Thank you very much. And would anybody like to ask any questions?
Thank you so much, Rory. Question time for Rory. There was an interesting discussion going, Rory. They say, how do you argue with the robot? I said, just bring it to South Africa. There's so much load shedding.
I know. I have to smile when I hear them here talking about, what will we do if there's power cuts? And
we're having load shedding right now. I mean, everybody's just on and off, and then you see them go, and then they come back on. They don't hear the little generators going. It's just a joke.
Yeah. Well, I mean, the other thing, I was in Cape Town. Was that 2018 when they were 2 weeks away from day zero and cutting off the water supply?
Yeah.
They introduced a hose pipe ban here a couple of weeks ago, and they thought that was the end of the world.
Oh my
You're going to
word.
have to wash your car with a bucket and water now.
Okay. Any questions for Rory, guys? I think we've got a hand up. Do we have a hand up? No, they seem
Yes,
contained,
Prof.
Rory. Oh no, there's
Yes,
somebody.
Prof.
Who's
Yes.
talking.
I just have a question regarding the new industry 4.0, right? Is there a chance this industry will evolve to a point where humans gonna start losing jobs? If we look at a company, there's a company in London called Ocado, I believe,
Yes.
where most of the stuff is done automated. Robots are doing most of the order for customers. There's no human interaction in there. Is there a possibility this industry will evolve to that point where we're gonna start losing people on certain jobs?
Yes. Well, that would be, Ocado would be similar to Amazon.
Yeah.
I forget. I think one of the big supermarkets is buying Ocado. I don't know if it's Tesco's or because it's not just what do they call it? Deliveries, online deliveries.
Take a lot, Russ?
I beg your pardon?
Take a lot.
Yeah. So there's a number of them out there. Are they taking jobs away? They'll take them away from one area, but they tend to grow in the other area. So if you think of the whole construction of their production line, think of all the jobs that created, the maintenance, the upgrading, all the software systems. They've still got the transportation to, this will be to individuals. You could argue that it's actually created more jobs, but I don't know the details. But you are right, it is going that way.
Thank you, Prof. Thank you.
Peter, can you tell me what other presentations you've had on this seminar?
Rory. So a lot of project management, where people have actually what kind of projects they've done, and then whether they've used Agile or whether they used Waterfall. We always have Grant, which is the CEO from Fed Group, and he sort of always tells us, you know, how they're doing projects, but more how does he incorporate all the information back in. We have JB yesterday. She was sort of like the product owner with Castle Light. When they rebranded Castle Light, I just showed us, you know, they had how important stakeholder management is, and how important that whole sponsor support is. But the rest very much on you know, either practitioners in project management or specific Agile practitioners. So it's all been very much around the project management, or where we've used project management, where they've used the project management.
Right. Okay. Well, I hope that has been helpful, and I've enjoyed giving that presentation. Peter, and Marie, thanks very much for organising it.
Thank you, Rory. Always so nice to have you for this bigger series.
I said you're still in the locker room there, yeah?
Yes, I'm still in the locker room. I'm going to a different room just now.
Yeah.
Ladies and gentlemen, anyone else perhaps have a question?
Your mic is up, Marie.
Apologies again.
I just know it because yesterday when I couldn't hear you turn it back up.
Thank you, Rory, so much. Really do appreciate it.
Okay, thank you.
Thanks, Rory.
Thank you very much, Rory. It was very nice to meet you like this.
Thank you.
Thanks, Rory. Guys, all the APMs, can we just quickly pop back to the class? See how used we are with AI, Rory. We talk about the class instead of Blackboard.
You're back at class, Prof, and thank you, Rory.
Thank you.
Thanks, guys.